This is Her Majesty Easy World Science. My name is Mr. Chinedum, and today I'm here to handle you on physics, the father of all sciences, where all others take their life from. Now, we're dealing with the JAMB scheme, and as you can see on the right of the screen, on this section, you can see the JAMB scheme. The first thing there we have are measurements and units. Under here, we'll learn about length, area, and volume. Here we learned how to use the meter rule to take a reading, vernier calipers, micrometer screw gauge, and measuring cylinder, how we use them. We're able to identify the units of length, area, and volume. We also learn how to use different measuring instruments, determine the length, surface areas, and volume of irregular bodies. That's for the first section. Now let's start. What exactly is length? It's the distance between 2 points. Length is the distance between 2 points. If somebody is at Enugu, another person is at Lagos, you want to check the distance between them. What you check is the length. You draw a line between two of them, and you get the length of the line. That length gives you the distance between the 2 points. Okay? And then, what exactly is area? Area, what is area? Area is the region bounded by lines. For example, I want to find the area of this shape. This is a shape known as, well, this is a square. Now, if I want to find the area, look at this blue, this region. This region, that's light blue. If I can find how much of it, that's called the area of the shape, okay? Now, every area is bounded by straight lines, and these lines surrounding it, these straight lines are what will help me to find the area of this shape. That means getting the area still boils down to length. What exactly is volume? Volume has to do with three-dimensional shapes. If I have this shape, now how much water will I pour into this to cover it? That's what is called the volume of the shape. Okay? This is a cube. So if I can get how much water will enter inside this place to fill it up, that would be the volume of the shape. Once again, how do I get volume? It boils down to getting this measurement, length, this measurement, height, another length, this measurement, which is the breadth, another length, breadth, and height. All of them boil down to length. So you find out that measuring volume involves measuring length and then computing it. Okay? Now let's go over to the materials we use to measure length. What are the materials we use to measure length? Number one is what you call a meter rule. On the right side of the screen, you can see this meter rule. If I want to use it, this meter rule to measure, what I do is, for example, I want to measure the distance between this line and this line. These two lines that form this column. I take my meter rule. Unfortunately, this meter rule has no readings, but go to the extreme left one, usually the zero reading. Let it align with this. See this point here? This is what we check. Our zero has to fall on here. Whatever reading I have here is going to be the length of the line. Now, if these readings are 1 cm, that means this is 1 cm, this is 0 cm, 1 cm, 2 cm, 3 cm. That is 3 cm. This is 1, this is 2, and this is 3. This is 3 cm, 3 points. These small ones are the points there. So we count, each small one is 1. This will be 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7. This will be 3.7 cm long. That's how you measure using a meter rule. The same thing happens when you're measuring using a ruler, measuring using what you call an odometer, that is used to measure distance of very long distances. Very long distances are measured using odometer. If you want to measure the length of a road that spans from here to Abakaliki, you don't use a ruler or a measuring tape. Use an odometer and run the whole length. The same principle lies with, measuring it follows the same principle. Now, what are the instruments we use for measuring length? Number one is what you call it's in a meter rule. Second one is what you call a vernier caliper. What is a vernier caliper? Look at the left of the screen. This is a vernier caliper. It's used to measure distances of objects that are quite small, but not very, very small. For example, your test tube, you want to measure the thickness. This is what you use. Okay? These are the jaws. You clamp your instrument within the jaws, what you want to measure, and then you move this screw clamp either forwards or backwards until it's tightened within the jaws. Once it's tightened, you use these rulers here. There are two rulers. This is your main scale, and this is your vernier scale. The two of them work together to be able to get you your vernier caliper reading. So, how do we use this? Now, how do we use a vernier caliper to measure? Look at the drawing on the left of the screen. I told you, remember we said that these two work together, both the main scale and the vernier scale. Now, what you do is, look at this reading on the vernier scale. Check the last reading on the left of the main scale that tallies with this. This, remember, this is 20. Since there is graduated in 20s and 30s, that means this reading here is 21, this will be 22, 23, 24, 25, and so on. So the last reading before this zero reading is your 23. So this becomes 23 points. We now move over to the vernier scale. Look at all these lines on the vernier scale. Find the one that matches exactly with a line on the main scale. Look, these ones are far off. Look at this 0. It's a bit far from here. 1 is far off. You keep going. It happens to be in this region. Now look at 5. It doesn't match exactly. 5.5. It looks as if, but not exactly. 6, 7. Now this 6 is the one that matches exactly with this. That means our reading, remember the original one was 23.60 cm. That is our reading here, 23.60 cm. That is the vernier reading for this instrument, this shape here. Remember, place it till it's tight. This thing obviously is tight here. We'll now take our reading and we got the width of this as 23.6 centimeters. And that is how you use a vernier scale to measure. Once again, use vernier scale to measure things like a test tube, the length of a test, the width of a test tube. Now, this portion of this is called, this portion is used to measure the inner parts, while this is used to measure the outer diameter. These are called the jaws. This is a jaw, this is another jaw. But this jaw is used for the inner, while this is used for the outer diameters, or the internal diameters and the external diameters. Okay? Now, if you want to measure this internal diameter, you use this portion. Put this inside and move your screw clamp until it gets there. The external, move it here and move your screw until it's tight, and then you take the measurements. Now, which other instrument do we use for measuring? From our scheme, you can see the talk of micrometer screw gauge. Now, what's a micrometer screw gauge? Look at this. Assuming you are told to measure things that are in the order of micrometers, for example, the thickness of a pin. You can't use a ruler to do that because it's too thin. Also, your vernier caliper can't do it. That's what gives rise to micrometer screw gauge. It gives you very, very thin writings. What you do, place your instruments between this anvil and the spindle. You turn this your thimble until it becomes tight within this region, and then take your reading on this sleeve. You lock it in and take your reading here so it doesn't fall off. Now, these two scales work together just like in your vernier caliper. These two scales work together. How do they work together? Now, let us see how they work together. Look at this. Take a look at this. This is the sleeve. This is how it looks like up close. So how do you use this sleeve to work? This is the main scale, and this is the smaller scale. It's not called the vernier scale because it's not a vernier caliper. Now, the same principle works. This is 0, this is 0 here. This is your 1, this is your 2. This is 0.5, a 1.5, 2.5, and so on and so forth. Now, these two work together. We check the last reading before this long line here, the last reading from this section before this one starts. In this case, it is 2.5. That's it. 2.5 is what you have. Remember, this is 0, 1, 2. This side is 2.5 that occurs before, so we put 2.5. Come to this section. Which one tallies closest to this line here? This is 35. If this is 40, it means that the readings here are 35, 36, 37, 38, 39, and 40. So the one that tallies the closest is 38. So what do? We take this and add it to this section. Add it after the decimal point. So we add, obviously this is a 0 here. So this is 0 plus 8 is 8. 5 plus 3 is 8. Points, this 2 comes down. So the reading we're having here is 2.88. Micrometer screw gauge is in the order of millimeters. So this is 2.88 millimeters. That's how you take your readings on your micrometer screw gauge. Now, which other instrument is mentioned here? It's your measuring cylinder. What is your measuring cylinder used for? Used for measuring things that have volumes of things that have irregular shapes. What does irregular shape mean? If you are given a cube, for example, you can easily take the length, breadth, and height. What if you are given a stone? How can you measure the length, breadth, and height? That's not possible. So we measure the volumes using a measuring cylinder. Archimedes' principle is what occurs here. When we go to Archimedes' principle, we'll go into more details about why it's like that. Now, how does it work? Look at this. This is your measuring cylinder. You see it in your laboratories, okay? You pour water to it and take it to a particular level. You take the reading from the lower meniscus. Don't take a reading from here. It's going to be wrong. Your reading is with one that tallies with here, this bottom portion. From here, your bottom portion is 60. So we note it. Your bottom portion is 60. You take your irregular shaped object, dip it into here fully. Dip into this, our measuring cylinder. It gives rise to this situation. In this scenario, look at where the bottom here is. What the bottom here, as we can see, is 80. So we have 60 and 80. When you dipped it moved to 80. It was 60. So what do? We just take the two of them and you subtract them. 80 minus 60. And the volume here is 20. This is in ml. And that is the volume of that irregularly shaped object. Okay? Now, I'm sure we are familiar with, this is a drawing, but let's see what this actually looks like. Many of us are familiar with this. I'm sure you've seen this in the laboratories you're in, or where they do all the soil tests, or even sometimes in your medical laboratory, you can see things like this, because they use some of them to gauge chemicals in the lab. So these are the instruments we use to measure. Once you are familiar with this, according to our scheme, you can see that once you are familiar with the vernier caliper, micrometer, screw gauge, and measuring cylinder, we have known a lot of things we need to know about measurements. So it's about applying them now that remains when it comes to our JAMB questions. Now, something else you have to know is this: the units of length, area, and volume. Remember, to get the length of an object, like we told you, take your ruler, align it, let it start the 0 points, fall exactly where what you want to measure is. Then take your reading at this point here. Whatever reading you get here is what it is. Now, this length will be your length of the instrument, of what you're measuring. Whichever length you get. Now, in this case, remember, we have here 0, here, this is 1, this is 2, this is 3, and this is 4. We have 4 points. Let's look at the smaller ones. 4 points is only one that is here. What you do, check the instrument you are using. If it's a ruler, it's going to be either cm or mm. Most rulers are in cm. It will be in centimeters. Now, for length, we measure it in what we call 2 decimal places. You never leave your length as just 4.1 or just 4, for example, if it's 4. We always add 2 decimal places to it. That is your degree of accuracy. So this thing I measured here, if I want to record it, I'm going to record it as 4.10 cm. Because length must always be in 2 decimal places. If I measure and I get 8, for example, I can't leave it as 8. I'll write it as 8.00 cm. Because length is always to 2 decimal places. Please let us note that, because there are JAMB questions like that ask us that. We must note, and that is always very, very important, okay? Now, the next thing on our agenda is area. How do we measure area? Area is simply, if I want to measure the area of this shape, it's what you call a 2-dimensional shape object. All you need for it are 2 things, the length and the breadth for your 2-dimensional shapes, okay? Now, if I want to measure the area of this shape here, all I need to do will be to get the length. The length is the distance from here to here. I put my tape on my ruler, measure this distance. Let me say, for example, it gives me 2 cm. Remember, it's 2.00 cm, just 2 cm. Remember, it's 2.00 cm. I've gotten one reading. I need a second one because, like you said, it is a 2-dimensional shape. You only need to get 2 readings from it, or 2D shape. I get my length. Another thing I do is I get this measurement from here to here. This is called the breadth. Let me say I measure it and I get something like 3.00 cm. What I do is, to get the area is very simple. Remember, in our primary school, we are taught that area of this quadrilateral, anything that has 4 sides, the area will be given to you as length times breadth. So I take my 2, multiply it by 3, and I'm getting 6. How do I do the units? The unit for length is cm, or meter. For breadth, for this particular case, as under cm, cm times cm is cm squared. That tells me that the unit of length can be, if it's in cm, is cm squared. If it's meters, meters squared. In millimeters, millimeters squared. Now, the SI unit of length is meters, so for area will be meter squared. But if your reading you're calculating with is in cm or millimeters, and you don't need to convert, so you simply use cm squared or mm squared. That is the unit of area. What about volume? When we want to deal with volume, we're dealing with what you call a 3-dimensional shape. Why is it 3 dimensions? There are 3 things we can measure from it. We can measure the length, the breadth, and the height. If I want to measure it, what do? I measure, just like when I did my area, I measure this. This will give me my length. Remember, volume is equal to the length times, I measure this region. This is my breadth times, I measure this thickness. This will be my height. Remember, each one has cm, 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 or meters, 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 or millimeters, millimeters, millimeters. So if I want to calculate the units, what I do is I take, let's work with meters. Meters times, this one has a unit of meters, times has a unit of meters. Meters times meters times meters means meters cubed. So the units of volume will be meters cubed. Now, we've covered their units, the instruments for measuring them, how to determine them, how to actually measure them. Now let's move over to JAMB questions and see practically what we can do with this. Before we move to that, next up here is mass. Okay, now we'll talk about mass. What is mass? Mass is the amount of matter in a body. The unit is in kilogram. The SI unit is kg. You know, sometimes you can use things like grams, milligrams, or even tons in some very, very, very rare cases. The 1 ton is 1,000 kg. And 1 milligram is 1,000th or 1/1,000 of a gram. And kg is 1,000 grams. The unit of mass is kg, like I said. How do we measure mass? We use simple beam balance. This beam balance, what does it look like? Well, I know that it's no longer common, but look at this. It works on the principle of moments. Very simple. Where you place a mass on the known mass on this side and then balance it on this side. Use this known mass to know the unknown mass. Or you place an unknown mass here and keep placing known masses on this section until you get a balance. Now that's the concept of beam balance. That's how it works on the principle of moments. Then time. Unit of time, of course, is seconds. Now before we go to time, there's another balance, something else we use to measure mass. That's called the Buchart's balance. The Buchart's balance is not common these days, but it's still being seen in these old government offices. For example, where they do soil testing for roads and so on. It looks exactly like this on the screen. So you can see it here. What do you use it to do? You place the mass here, and the reading comes on this scale. Okay. That's the Buchart's balance. Most of these work on the principle of moments, okay? Whereby the sum of the clockwise moments and the sum of the anti-clockwise moments will be the same. That's what it looks like. Now, time. What exactly is time? Time is the interval between two things. Time is not just a measurement of the time of the day, the period of the day it is, no. If something starts happening by 6 o'clock and finishes by 6:20, the time taken is, you subtract these two and you're getting 20 minutes. That's why you usually call it time interval, not just time. Okay? That a bird arrives by 6:20, starts off at 6, arrives at 6:20, doesn't mean you should take the 6:20 to calculate. No. What you need is a difference in the time between two of them, which is called your time interval. What do you use to measure time? Of course, your clock, your stopwatch. For bigger readings, you take your calendar for years and days and months and so on and so forth. Unit of time. Time is in seconds. Unit of time is in seconds. I hope you remember that 1 minute is 60 seconds. And then 1 hour is 60 minutes. That same 1 hour, to get it in seconds, just do 60 times 60, and it gives us 3,600 seconds. Now, whenever you're working any of this, make sure that all the units are the same. That means if your question has kg and grams, make sure you move all of them to either grams or all of them to either kg before you start calculating. If they give you a question that contains that discrepancy, please don't make the mistake of using the values like that. Make sure you convert it first before you solve using that. Okay? Now, what are devices for measuring time? To measure in seconds, you have your stopwatch, your normal watch. Minutes, stopwatch can do that. Hours, same stopwatch can do that, or your hourglass. But bigger values of time, such as days or months or years, you have your calendar to do that, all right? Now, having put this in place, let us go straight to the JAMB questions and answer some JAMB questions on this topic. If you look on the screen now, here's a screenshot of JAMB questions. So let's answer them as much as possible. Now, ignore this. Make sure to ignore this section, these answers. These answers are not always correct. So let's work on them and see how we can get them. Question 1 says, to determine the weight of an object, you could use a beam balance, use a spring balance, find the force necessary to give it a certain acceleration, or use any of these methods. Now, you can use a beam balance to find the weight. Beam balance is measure masses, but of course, if you measure the mass, you can get the weight. Okay? Now, use a spring balance. Spring balance, most of them are graduated in both kg and newtons. Remember that weight is in newtons. So you can use a spring balance to measure weight directly. Beam balance can give you mass, then you get weight. Spring balance can give you weight directly. You can find the force necessary to give it a certain acceleration because according to Newton's second law, the force is proportional to the mass and the acceleration. The acceleration, of course, mass is constant. If you can get the acceleration and you know you can measure the mass, of course, you can get the weight of the body. So any of these methods is the most correct option. Use any of these methods. Now remember that in JAMB, sometimes they give you more than one correct answer. What they're looking for is the one that is the most correct, that captures it the best. So in this case, use any of these methods. Of course, JAMB is not like, they don't show you any steps, so you can't say you can get half mark. Look for the one that has the best option. Now, number 2 says, one of the following readings represents the measurements of the length of a metal rod using vernier calipers. Before I go ahead with this question, let's mention what is called degree of accuracy. Whenever you're measuring length, you have a degree of accuracy of 2. What that means is this. If I measure an object and I get a reading of 2.5, I don't record it as 2.5. I must always have something behind, which is 2.50. If I measure and I get 7, for example, on the dot, what I do is I put 7.00 cm. So once its length is always degree of accuracy of 2. But both mass and time have degree of accuracy of 1. That means if I measure mass, I get 3 kg. You can leave it as 3.0, 3.5. These ones are acceptable. Time, 4.8 seconds, 7.3 seconds. They're all acceptable. So, having that in mind, the question says, using vernier caliper, I want to measure length. Length is always 2 decimal places. So look at the options. Number 1 is 5.16. This is 2 decimal places. So it's possible. 5.165, 3 decimal places. That's off. 5.0, 1 decimal place. That's wrong. 5.160, 3 decimal places. That's wrong. Meaning that the correct answer is 5.16 cm. Okay. Number 3. Which of the following statements are true about the spring balance and the chemical balance? Both are used to measure the mass of an object. Of course, both of them are used to measurement of the object. Okay? So I is correct. Note that. Either of them may be used to measure the weight of an object. Now, can we use both to measure the weight of an object? Of course, you can use them to derive the weight of the object. Can we use spring balance to measure weight? No, but yes, because we can use to calculate the weight, but to measure the weight. Now, can we use spring balance to measure? Yes. So number 2 is also correct. Number 3, the spring balance works on the principle of the Hooke's law, while chemical balance works on the principle of moments. Of course, spring balance has a spring in it. Anything spring works with Hooke's law, while chemical balance works with principle of moments. So this is correct. Number 4 says, a change in gravity changes the readings of a spring balance, but not that of a chemical balance. The question is that correct? Now, for a spring balance, for a chemical balance, of course, it's just balancing things on both sides, so gravity doesn't affect it. But for spring balance, it works purely with gravity. That means that actually a change in gravity will change the region of a spring balance, but not that of chemical balance. But the question is actually correct? No, because spring balance measures mass. Change in gravity doesn't change the mass. So watch this. We have I, and I as being correct. So that means our D is correct. Remember, spring balance can measure mass. Mass is not affected by gravity. So anything that is gravity, once gravity changes, mass remains the same. It doesn't matter. It's only weight that's affected. So it's when you're measuring weight that gravity is affected and not mass. Number 4 question says, which of the following represents the correct precision if the length of a piece of wire is measured with a meter rule? Now, Your meter rule. Everything length, once again, has to be 2 decimal places. Remember that, right? Good. Now, when is a meter rule? There are 2 conditions. 1, it has to be 2 decimal places. Number 2, the last digit has to be either 0 or 5. With a meter rule, you can never get something like 2.36 is incorrect. You can get 2.35. You can get 2.50. Now, assuming you get a reading that falls in between, let's say, 2.5, you are seeing a reading in between 2.5 and 2.6. Even though it's closer to 2.6 or 2.5, you must read it as 2.55. It doesn't matter where it's closer to. So when we note these things, you cannot get the answer to this. If you're using a meter rule, 2 conditions, it must be 2 decimal places. Look at our options in this question. That eliminates option 1, option 2, and leaves us with options C and D. Which one ends with either 0 or 5? That's option C. So that becomes our correct answer. Number 5 question says, what is the least possible error in using a rule graduated in centimeters? In centimeters is your normal ruler, okay? Is it 0.1 cm? Is it 0.5 cm? Is it 1.0 cm? Is it 2.0 cm? Now, the least possible error is how much the least thing you can actually measure. Using a meter rule, can you measure up to 0.5 cm? Can you measure up to 0.1 cm?
A meter rule graduated in centimeters usually has the smallest graduation of 1 mm or 0.1 cm. Therefore, the least possible error in using a rule graduated in centimeters is 0.1 cm. If the meter rule is graduated in millimeters, then the least possible error is going to be 0.5 mm. The correct answer is option A.
Question number 6. What is the reading of the vernier caliper shown below? Here we have 1 cm, here we have 2 cm. Remember the rule. Look at the 0 mark here. This is the 0 reading. So we check which one is the one before the 0 reading. That means we have 0 is 1.0, 1.1, 1.2, 1.3, 1.4. So what we have is 1.4 before the 0 reading. Now check which one matches exactly from the top and the bottom. Sorry, let's do this again. This is 1.0, 1.1, 1.2, 1.4. So the one we have is actually 1.3. Which one does the top and bottom match? This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Look at this 9. This 9, top and bottom matches. So I take this reading at the 9, at the bottom here, from the vernier scale. It becomes 1.39 cm, making my answer to be C. Number 7 question says, the inner diameter of a small test tube can be measured accurately using, is it micrometer screw gauge? Is it pair of dividers? Is it meter rule? Or is it pair of vernier calipers? Now, your micrometer screw gauge measures things that are in the order of millimeters. Your inner diameter of your test tube is not in millimeters, it's in centimeters, so that rules out A. Pair of dividers has no graduations, so it won't work. Meter rule is too big to use to measure it. You can measure things in bigger cm. It's difficult to get that gauge because it's difficult to, since it's a circle, okay, you have to have something that can accurately take the biggest parts, which is the diameter. Remember, diameter is the longest chord in a circle, okay? Now, to get it accurately, it has to be a pair of vernier calipers to get the inner diameter. If you remember when we talked about vernier calipers, these jaws you see here, those are what we use to measure the inner diameter of a test tube. Look at this thing here, assuming this to be a test tube, okay? As it's clamped here, you can measure the outer diameter. But if you want to measure the inner diameter from here to here, you take this, place it inside these jaws at the top, then you can get your reading. So the correct answer here is pair of vernier calipers. Okay? Now question 8 says, The length of a piece of a glass block was measured by means of a vernier caliper, as shown below. The length of the glass block is, now remember the rule once again. From what we see, this is our 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, what's the last reading here before our 0 starts? This is 1, 1.5, 1.6. So we're going to have on this side, we're going to have it as 1.6. We now go and we check for the one that matches exactly the one at the top. Okay? This is, now look at this. This place 4 is supposed to be. This mark was carried up. I'm guessing it's a typographical error. So this is one that seems to match the most. That makes it 1.64 cm, meaning that B will be our correct answer. Now, question 9 says, diameter of a small ball bearing, thickness of a piece of paper, diameter of a measuring cylinder, length of a piece of wire. Which of the above can be measured using micro screw gauge? That's micrometer screw gauge. Which of them are so small that it's a micrometer screw gauge that can do it? Of course, thickness of a piece of paper falls in there. When you want to measure diameter of a small ball bearing, it's not so, what's it called again? Precise, but if it's a tiniest small bearing, since they said it's small, micrometer screw gauge should do it. Diameter of a measuring cylinder, that works for vernier caliper, not micrometer screw gauge. Length of a piece of wire, a ruler can do that. Meaning that our best options here are I and II, meaning that B should be our answer here. Okay?